All right, so today's lesson is over what we call inverse trig. We've done inverse trig before. You've done it in your calculator. It's when we find the measure of the angle. We had to do it with law of sines and cosines if we were looking for an angle. You did it in geometry. So if y'all will take out your calculator for me and put your calculator in degree mode, I want to ask you a few questions before we start on the notes. All right. To do inverse trig, we hit the second key, and then the sign, and then let's hit the sign button, and it looks like a sign of to the -1, but that just represents inverse. It's telling the calculator, hey, I'm going to put the ratio, the sign ratio in the parentheses. I need you to give me the angle. So if we were to use, hold on, pause. Okay, this is Miss Battles. Okay, thank you. Bye-bye. All right, Mark, you didn't even make it through half of it. We'll see. It's not pretty for your picture. Okay. Oh, it's going now. All right, so if we typed in, let's do 1/2. We know that the angle that has a sine ratio of 1/2 is pi over 6. When we put it in the calculator, we should get 30 degrees, right? Okay, but my question is, what other angle has a sine ratio of 1/2? There's another one in the unit circle further around. Where else is the sine ratio positive? It's positive in quadrant 1 and quadrant, not 3, but
4.
Not 4? 2. Okay. And at what angle in quadrant 2 has a sine ratio of 1/2? 150, 150 degrees, or 5 pi over 6. But notice it didn't give us 150 degrees. It didn't give us a choice. It just gave us 30 degrees. That's important. Remember that. It just gave us quadrant 1. Now, if I type in inverse sine of a -1/2, where are my sine ratios negative? In 3 and 4. And so if I hit enter, notice it gives me a -30. Where is -30 on the unit circle? There you go. Yep, it goes back. It's coterminal with 11 pi over 6 or a positive 330 degrees. So it just goes back right here. We call that negative direction, negative quadrant 1. Okay? So it didn't give us the angle that's in quadrant 4, nor did it give us the angle that's in quadrant 3. It gave us this angle. All right. So now then, with that in mind, let's take a look at the very first item that we're working with. We're going to be working with sine, and I want you to graph the sine function, the sine parent function in its, just with its 5 key points. Remember, they are 0, pi over 2, pi, 3 pi over 2, and 2 pi, with the output of 0, 1, 0, -1, 0. And we're going to graph that. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. Okay. Now, here's where I saw some issues. I saw people just draw straight lines connecting these points, so it was like a chevron pattern. This is a curve. I need to see the curve. And then right here, I saw people with arrows going up, like up to positive infinity. The range doesn't go to positive infinity. It only goes up as high as 1, so we want to be careful about how we end end it. And right here, I'm just going to stop right there. But I do want to go backwards and fill in this portion of the graph. Now, this is what I saw people struggling with, was where to put our points going backwards. So the beginning point here is the same as the ending point here. But this point actually begins the next rotation. So if I were to go backwards and then go backwards here, these points, that would help direct me as to where I should plot that next point. Because I had a lot of people want to go ahead and go on back up. But no, it's got to go all the way down to its lowest point, then go all the way back up. All right? And then after we go here to our negative pi over 2, we're going to go up to negative pi. Plot a point, and then go ahead and curve that around. All right? And I call these definitive points. What I don't like, and because this goes back when I taught Algebra 1 and taught students how to graph lines, they would just type it in their calculator and kind of look and see where it was and just go, whoop, and just draw like a line just randomly on their paper. And I was like, no, I want definitive points. I want to know what points they go through. And it's the same thing here with these. I want to know definitive points. Okay, so now I've got this graphed. Now, do you remember how to graph an inverse? Or what is an inverse? If we're given a table of values, there you go. You flip the y and the x. So they are the inverses of each other. They reflect across the graph of y equals x. But if we were given a table of values, then we can just go ahead and swap them. So for our inverse, the first point is 0, 0. The second point is 1 pi over 2. Then we've got 0 pi, negative 1, 3 pi over 2, 0, and 2 pi. Notice that your graph, the x-axis, has numbers, whole numbers, integers, and the y-axis has the degrees and radians. It's just the opposite of our original graph. Okay, so our input is 0, 0, so we're starting right here at the origin. Then we're going over to 1 pi over 2. So we plot a point right here. Then we go back to 0 and up to pi. Then we go to negative 1 up to 3 pi over 2. Back to 0 up to 2 pi. Obviously, this is not a function because it doesn't pass the vertical line test. I've got multiple output values for the same input. But when we connect these points, we're going to wrap them around, and it's going to be like a little S curve. And this is our inverse sine, not a function. But if I were to continue this going the other direction, so I wrapped around here and went to 0, 0, where would I plot the next point? Negative 1, negative pi over 2. Then, where would I go? There we go, back to 0, negative pi. Then over to 1, negative 3 pi over 2. Back to 0, negative 2 pi. So let's go ahead and continue wrapping this on around. All right, now, since this is not a function, remember when we had like parabolas or any of our other graphs that when we created its inverse, we wanted the inverse to be a function. What did we have to do in order to get a function with the inverse? we had to do something with these domains. Do you remember what it was? Because if it doesn't pass the horizontal line test of the original function, it's not going to pass the vertical line test. So we had to restrict the domains. So where could I restrict the domain so that I get all the points possible from my minimum to my maximum this way, but I don't repeat values? Where could I put my restrictions on here? Anybody got any ideas? Let's look at quadrant 1 right here. Would the inverse of this portion work? Are there any repetitive values? No. What about if I continued around into quadrant 2, though? Would that work? No, because my input values, it doesn't pass the horizontal line test. Therefore, that means when I did my inverse, I would have multiple x value, the same x value with multiple y values. So that wouldn't work. So we can't go this way. What if we went backwards over here? Does that work? Would any of these have repetitive values for the inverse? No. So let's go ahead and highlight that section right there. Okay? And where does this section from -1 to +1, where does that work over here in our inverse? Can y'all find it? We know our origin. So -π/2 to +π/2 would be our range right here. -1 to +1 would be our domain. So if we restrict our domain of our original function, then we have an inverse function. If we don't restrict it, we still have an inverse, but the inverse isn't a function. Now, I want you to go back to looking at your calculator. When I plugged in values from my first my sine ratios, and they were positive, it gave me a value in quadrant 1. Sine of +1/2 is 30. When I used a negative ratio, it went back into negative quadrant 1 and gave me the angle -30. It's not going to give you anything over in quadrants 2, 3, or 4 because they're restricted. We can't get and have an inverse function if we use these. So that's why it's going back the other direction. So let's go ahead and graph the inverse right over here. So we've got our point at 0, 0, -1, -π/2, +1, +π/2. And this is not a line, but a curve. Okay, it's kind of a little squiggly there. Those are the only values, input and output values, that we're going to be using. So how that works with our unit circle. Okay, here's our unit circle. We've got our x and our y axis. We start at 0. We go to π/2, around to pi, 3π/2, and then back on around to 2π. Okay, but if we are only allowed to use quadrants 1 and -1 for our inverse, then we're only using the angles from 0 to pi over 2 in quadrant 1 and 0 to not 3 pi over 2. What would this angle be if we're going the negative direction?
0 pi.
So from 0 to, if we're going a negative direction, so negative pi over 2. So this is now negative pi over 2, because we're going to call this quadrant negative 1. So if I have a positive ratio, our angle that we're looking for is going to be in quadrant 1. If I have a negative sign ratio, my angle is going to be in quadrant negative 1. So it's just going to be the negative version of whatever I have here. All right, so now then, your inverse sine function, this is what you're restricted to. Your domain values and your range values of the original function. This is all we can use. That's it. Only use these angles for inverse sine. All right. Now, this is what the questions are going to look like and how you apply them. Apply this information. If you will flip and look on page 13, okay? On page 13, I've got some more information up here that kind of explains a little bit more about your inverse. But something that's important that I need to point out is that it's on the restricted domain that y equals sine x has an inverse function called the inverse sine, which is y equals inverse sine x. And this inverse function is also referred to as the arc sine function. Now, y'all may have seen this in geometry. Arc sine is another way of saying, what angle am I looking for? Inverse, we're looking for an angle. Arc, we're looking for an angle. So when you see that term, arc sine, arc cosine, arc tangent, it's the same thing as inverse, and it says you're looking for an angle, not a ratio. So if I were to type in a positive ratio into my inverse sine, I'm always going to be looking at quadrant 1. But if I type in a negative ratio for inverse sine, I'm going to be looking at negative quadrant 1. That's what I need you to pay attention to. And notice the only difference is the angle's going to be negative. Okay? So down at the bottom, there's 10 different examples. We're only going to look at the sine. So number 1 is sine. And this is read, the inverse sine of 1. Well, what angle has a sine ratio of a positive 1? 90 degrees. What is that in radians? That's your answer, pi over 2. I'm looking for the angle that has a sine ratio of positive 1. And that is that's actually the only one possible. But notice sine pi over 2, that is within our restricted domain because I'm going here from 0 to pi over 2. Look at number 3. This is asking for the inverse sine of 1/2. Well, we just did that one. Where is sine a positive 1/2? 30 degrees or? What's radians? Pi over 6. So we've got pi over 6. Okay. What is the reciprocal of sine? Cosecant. Cosecant is the reciprocal of sine. So on number 6, we have the inverse of the cosecant right here. I'm going to change that to the inverse of sine and flip my ratio, because I know those. Where's my sine ratio equivalent to root 3 over 2 in quadrant 1? 60 degrees, which is pi over 3. So my answer is pi over 3. And if you were to type these into the calculator, folks, it will give you the answer in degrees. If you have it in radians, it will not give you pi over 3. It'll give you a decimal. You can try it and see. Okay? But you have to be able to do these without a calculator. They're all going to be our special right triangle angles, though. There's not going to be any foreign ones in there. All right, take a look at number 7. This one is arc cosecant. Arc, we could write that as inverse cosecant. And I don't do cosecant, I do sine. So inverse sine. Well, what is the reciprocal of 2? 1/2. So I am looking for the sine ratio of 1/2, and we already did that up here, and that was pi over 6. So you are looking for the angle. Anybody got questions? On any of that we did? Go back to page 12, because we're going to do the same thing this time with tangent. All right. So make a table for your tangent parent function. 0, pi over 2, pi, 3 pi over 2, 2 pi. And then you've got 1, 0, -1, 0, and 1. And plot those points. 0, 1, pi over 2, 0, pi -1, 3 pi over 2, oops, I'm sorry. What did I do? I did sine. I graphed sine. What? Dadgummit. And of course, I'm videoing this thing. All right. Let me find my whiteout. Never mind. Here we go. Let me just do it in red. We've got 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi 1. And when I connect those points, I'm going to have this curve. And remember, up at the top, we don't go beyond that to infinity as far as our range. We have to curve it on around. Okay, this one is a little bit easier. I can stop this right here, and I will go from my maximum to my minimum and hit all possible values before I go back up and repeat. This one is a little bit easier to restrict. So we're going to restrict it from 0 to pi. We're going to graph it over here. So we've got our inverse is 1, 0, 0 pi over 2, -1 pi, 0, 3 pi over 2, 1, and 2 pi. Plot those points, and the horizontal scale is counted by halves. So you got skip the first one to go to 1. Then you've got 0 pi over 2, -1 pi, 3 pi 0, 3 pi over 2, and 1, 2 pi. And we can go ahead and graph this going backwards, okay? Wrap this back around, 0, negative pi over 2, negative 1, negative pi, 0, negative 3 pi over 2, and 1, negative 2 pi. And we can go ahead and connect our points. But this portion right here is quadrant 1 and quadrant 2. And so we're going to go from 0 to pi. So on here, we're going to go from 0 to pi. And that's where our restriction is going to be. So if I was going to graph the inverse function, it would be the point negative 1 pi, 0 pi over 2, and 1, 0. And it curves like such. All right. So we've got our restricted portion so that we get our function right there. Now, when we apply that to the unit circle, 0, pi over 2, pi, 3 pi over 2, we know we're in quadrant 1 and quadrant 2. Quadrant 1 is where our positive ratios are, and quadrant 2, cosine is negative, so that's where our negative ratios are. But we are restricted to just use these. So what we did with sine, take your calculator, and we're going to do this with cosine, and we can go ahead and use the ratio 1/2. If you will type in the inverse cosine of a positive 1/2, what do you think you would get? Where's cosine a positive 1/2? 60 degrees. So we've got 60 degrees. But it's also positive in quadrant 4, right? At 5 pi over 3, or 300 degrees, but it's not giving us that because it's not in the restricted domain. Now type in inverse cosine of a negative 1/2, and guess what degree it's going to give you for that one? 120. And then everybody goes, but wait a minute, why isn't it giving us a negative? Because we're restricted to quadrants 1 and 2. Cosine has a positive ratio right here at 2 pi over 3, just like it does at pi over 3, has a ratio of 1/2. And so, therefore, we're looking at quadrant 2 and not negative quadrant 1. Okay? They're totally different. Our restrictions are different because our graphs are different. And we're graphing it so that we can have an inverse that is a function. So when you use your calculator to do inverses, it's only going to give you values in those restricted domains. All right. So now then, if you'll flip the page and look at page 13 again, all right, we've got restricting the domain between 0 and pi. You're able to have that one-to-one relationship. And just like sine, y equals cosine has an inverse called the inverse cosine, or y equals arc cosine. So you need to be familiar with this. They mean exactly the same thing. If you're given a positive ratio for cosine, you are going to use quadrant 1. But if you're given a negative ratio, you're using quadrant 2. So keeping those angles in mind, we're going to practice with our inverses right down here. All right, so take a look at number 2. You've got an inverse cosine of a negative root 3 over 2. Well, since this is negative, what quadrant am I going to have to use? Quadrant 2. Okay, so what angle in quadrant 2 has the ratio root 3 over 2 for cosine? 150, which is radians? 5 pi over 6. Arc cosine of 1/2. It's positive, so in quadrant 1, where is cosine? Or what is it? That's okay. What's the angle in quadrant 1 with a positive ratio? This is just the same thing as the unit circle, just backwards. What angle has a cosine? If I said cosine blank equals 1/2, what would that blank be? Pi over 3. All right, this is why it is so important to know that unit circle, folks, because you don't have time to draw a unit circle for all of this kind of stuff. You want to be able to know it right away.